Good evening, everyone, and a warm welcome to all of you at the workshop on Microgrid Tie Inverter of Department of EEE SRM VEC. SRM Valliammai Engineering College, a division of SRM Group of Educational Institution for Privileged Learning, is functioning under the Valliammai Educational Society with the noble vision of educate to excel in social transformation since 1999. The UGC New Delhi and Anna University Chennai have granted autonomous status approved by AICTE New Delhi and affiliated to Anna University Chennai, Tamil Nadu. The Electrical and Electronics Engineering program is duly approved by AICTE and affiliated to Anna University Chennai. The department is ISO 9001:2015 certified. National Board of Accreditation has accredited the BE program for a period of 3 years. The department prides for its 12 state-of-the-art laboratories with modern equipment, and it also has the AICTE sanctioned 2 MODREBs. The department also offers postgraduate programs in power system engineering since 2010. Taking our evening and further to begin with the introduction of speaker, I thank management, principal and vice principal for giving this opportunity and welcome HOD EEE Dr. K. Ilango and the speaker of the workshop, Mr.N.Sujith, who is the alumnus of our college. He is working as the technical assistant, electrical, TNEB Coimbatore. I welcome all our staffs and students who all joined for this event. I welcome Mr. N.Sujith, Technical Assistant, TNEB Coimbatore, to give presentation for the workshop. He is the alumni of our college who have passed out in 2021. He got certifications in hardware development using embedded systems, modeling and application of electrical systems using ETAP, industrial automation, modern business writing. He received Young Achiever Award in August 2020, Best Paper Award June 2020, Special Achiever Award March 2020. He was a campus ambassador international at MUN Global Education Forum. He got technical skills in ETAP, Python and Wonderware. He attended many conferences and published journal papers too. I welcome you, Sujith, for the presentation.
Thank you, ma'am. Thank you so much. Ma'am, am I audible?
Yes, Sujith.
Shall I continue, ma'am? Or?
You can continue.
Thank you, ma'am. Well, good evening, everyone. Good evening, sir. Good evening, ma'am. Good evening to all the students. This evening is really a memorable one. From being a student to department president and now as a resource person, the journey has been really special to me. And now I'm really happy in being the resource person for this particular workshop on Microgrid Tie Inverter. So all of us know about, if you just split the topics into 3, you know what is microgrid, you know what is tie. Tie is nothing but connected, and you know what is an inverter. But then when it is joined into 3 categories, I mean into a single heading, we'll have to technically know what is behind that. Microgrid tie inverter. So just give me a minute, I'll share the screen and start. Is my screen visible?
Yes, Sujit, it's simple.
Yes, Sujith.
Thank you, sir. Thank you, sir. Thank you.
Put in presentation mode, Sujit.
Yeah, yes, sir. Okay. So as I said, we'll be dealing with the microgrid tie inverter. Rather saying it as a workshop or any other thing, we'll just discuss about what is the thing, because I'll share my knowledge on how I came to know about this topic by few research. So the subject matter which we'll be discussing about in today's session is preface to what is microgrid and inverter, the basic introduction, followed by microgrid technology, what is a microgrid and its technology of it. Then we'll see about grid tie inverter, that is grid connected inverter in simple way. And then we'll look into topologies of inverter, different types of topologies, and one application which is in agreement with microgrid tie inverter. The application is nothing but force switch based three-phase grid connected inverter to connect renewable energy source to a generalized unbalanced microgrid system. This is nothing but we're just using the concept of microgrid connected inverter in this particular application, and that is how we'll come to know about what is a microgrid tie inverter and how it is going to work. Now moving on to the topic, microgrid. So if you say microgrid, it is a self-sufficient energy system that serves a discrete geographic footprint such as college campus, hospital complex, a business center or neighborhood. So we know like a micro itself is a small, a grid is something, a system, a connected system. So it is a self-sufficient energy system which is improvised itself that serves a discrete geographic footprint. Discrete geographic footprint here represents a small area. So microgrid is nothing but an energy system which operates in a small area, like a particular area or a particular locality, or in case an example given here, college campus, hospital complex, etc. So you can see the picture from the utility grid. We are connected to the microgrid. The microgrid supplies power to each particular area in a separate locality. That's how we'll define as a microgrid. Now, discussing about the types of microgrid, we can say many types. There are many types of microgrid because we can't restrict to one or two. But generally, if we classify, it is of AC microgrid and DC microgrid. Followed by that, it is also further divided into remote microgrid, grid connected microgrid, and networked microgrid. So these three are the major types of microgrid. So remote microgrid, they are also known as off-grid microgrids. So they are physically isolated from the utility grid, and it is operated in island modes. Island modes is nothing but single mode at all the times. So here there is due to the lack of transmission and distribution infrastructure nearby the locality, these type of microgrids can be used as remote microgrids. So additionally, if we see there many remote microgrids are considered for storage, especially for battery energy storage, and also for backup in conventional generators. This is the type of remote microgrids. Next, moving into grid connected microgrids. So these microgrids, they have a physical connection, exactly a physical connection to the utility grid um, with a switching mechanism or any other tool. So exactly, they'll have a physical connection to the utility, directly connected to the utility grid at a point known as common coupling. A point of common coupling, we'll say denote it as PCC. Through using a point of common coupling, this grid connected microgrids are, as the name itself suggests, grid is connected directly to the microgrid. So under this thing, we can say examples as medical complexes, like not restricted to a very small area, but to a complex system or any other a locality which involves many components inside itself. That is medical complexes, public safety, or traffic jam, and all those stuff. Military bases, even in agricultural farms or commercial buildings, etc. This grid connector microgrid are useful. Moving to networked microgrids, they are also known as nested microgrids. So the name nested microgrids here comes because they consist of several separate microgrids inside itself, and they are interconnected with each other. That's why it is called as networked microgrids. So this networked microgrids is also called as nested microgrids because of the name. It is interconnected itself. Example of this is closed loop self-healing. There is a process called closed loop self-healing, where community microgrids and smart grids also use this type of networked microgrids. These are the examples of network microgrids. So microgrids separately, you can define in three different characteristics. That is, it is local, it is independent, and it is intelligent. First one, microgrid is local. So what is actually local is nothing but why these three characteristics we are defining for microgrid is like these three characteristics can uh, be an example for a microgrid. Also, a microgrid can be of any type. Say, for example, it doesn't need to be a remote alone. A remote can be also there, or physically a grid connected microgrid also be there. All the three can be connected together and form a microgrid. So these are the types of microgrid. Next, look into the characteristics of microgrid. As I said, a microgrid is local. Like this distinguishes microgrid from large centralized grids. That is, they provide electricity for large microgrids, and these central grids, they push electricity from power plants uh, over long distances, not very small, over long distances through transmission and distribution line. So delivering power very far is inefficient because of some of the electricity, because as much as from 8% to 15%, they dissipate in transit itself. So this particular microgrid overcomes this efficiency by generating power close to those it serves. So the generators near or within the building, or also it can be in case of solar panels, or also in the roofs. That is why it is local. It is inside the system itself. A microgrid is independent. Why it is independent? Because it can disconnect from the central grid and it can operate independently. That is, it can stand alone and it can act. That's why it is called as independent. So this islanding capability allows power to their customers. They allows them to supply power to the customers in their need itself. Say for example, if you have any storm or any other calamity occurs, even if one microgrid is cut off, the other one which is connected will act as it will act independently, and that's why it is also called as island. So by this process of islanding, this microgrid, it escapes from cascading grid failures. The cascading grid failures, cascade is nothing but connection. So when there are three different types of microgrid are connected, when one is not working properly, or one due to any fault or any occurrences, the other one works properly, because it is very independent. Next, a microgrid is intelligent because these are very advanced systems. Though we know this concept very earlier, but then it still is under research, and there are many lot wonders can be made through microgrid. So this intelligence, why we say it emanates from what is a microgrid. Microgrid can be used as a controller, or what other, the central brain of the system. That's why it is called as an microgrid is intelligent. So this actually manages the generators, it manages batteries, it also manages the entire system, and the building systems is which has high degree of sophistication. When there is large power current failures, or when they need large amount of power, this microgrids serves as a better one for everything. Now, inverter is a very familiar topic to everyone, but then just to brush up, we'll say, it converts direct current to an alternating current, isn't it? Direct current here is nothing but, I'm just considering a solar PV as an example, for instance. That's why, which is what a solar panel generates. A direct current, it is generated by a solar panel. Now it converts into an alternating current, which the electrical grid is used. That is, the direct current will be used by an electrical grid. That is nothing but inverter. Now, types of inverter, as I already said, we can't restrict the types of inverter into a single chart. There are many types of inverters. Basically, we know VSI and CSI, that is voltage source inverter and current source inverter. There are many other types in that. The operating modes is different, as well as when it's connected to a particular system, it acts differently. So yet another classification of inverter is a square wave inverter, modified sine wave inverter, or sine wave inverter. Why I have mentioned these three inverters in this particular session is, by using these three inverter only, major applications or major research is happening through microgrid. That's why these square wave, modified sine wave, and sine wave are included. This modified sine wave is also called as a pure wave, or a central wave, which is majorly used in inverter topology. This is majorly used as an inverter topology when there is a research, or using even when simulation process happens. These three inverters forms a major role. Okay. Now moving on to microgrid technology. As we know, what is a microgrid? It is a very important one where we use and what and all things. But then the technology of microgrid has been evolved from a long back ago, just to reduce the amount of fossil fuel, or to reduce the amount of even power, or whatever it may be. This microgrid was introduced. Now, looking into the architecture of microgrid, as I said, it is of two types, like AC microgrid and DC microgrid. You can see the picture. AC microgrid is the left side one is called as known as the AC microgrid, and the right side one depicts the DC microgrid. This is the flow chart of architecture of both AC and DC microgrid. So these two types of microgrid are used. Any one of the types of can are used for one purpose, or even when where there are three types of microgrid. For example, grid connected or network microgrid. One can be an AC, and even the receiving or sending power can be different. Or both the types of microgrids can be used when there is a need of power in particular system which is connected. So we can't restrict the microgrid in uh, one single row, but we can use it for many other purpose by using the different types of microgrids which is available. So renewable energy source is actually the need of the hour for anyone, but then it meets the needs of electrical energy. But this microgrid is getting into attention as a solution of problems for all the electrical energy issues, particularly for the areas which they are difficult to reach power grids. So there are variety of solutions have occurred by using this RES itself, that is renewable energy source itself. Even from the use of energy sources, the development of power conversion, or even the system conversion, this application of renewable energy source in electrical generation systems, this is performed in variety of configurations, and that's how microgrid came into existence. And this problem, all the issues by using, even in case of when there is no availability of renewable energy sources, this problem can be addressed by adding another generated systems or another microgrid generated systems. Even in case of a large system also, as I already said, when there are, you can use three types of microgrids and connect it as accordingly through the needs. So this architecture, both the structure, you can see it consists of several types inside itself. You have solar panels. The DER is mentioned as solar panels. You have wind turbines, micro turbine for energy storage, thermal power plants. Like each, you can see it is in the form of distributed generation. We'll mention it as DG. It also includes energy reserves from battery. Battery is nothing but distributed storage, that is DS. This microgrid electrical connection is restricted towards a particular AC or DC microgrid, but then it is connected to low voltage network in the PCC. PCC is nothing but point of common coupling, as I already mentioned. So this is connected to a common point. The common point is the point of a common coupling, which is connected to distributed generated systems or distributed systems or loads, which consist of several types of loads. It can be as residential load or commercial buildings, campuses, or even industrial complexes. So this AC microgrid or DC microgrid, you can it is not necessary to use any one of the thing, but you can combine these both, and I mean connect these both and use it for your different purposes. Microgrid technology, the major use of microgrid technology now, it has been as an electrical storage unit. So this picture here shows the micro turbine which is used for energy storage device. So this energy storage in microsystem is used among many purposes. One is stabilization of microgrid system in the face of fluctuating energy sources and load changes, and it enables load sharing operation in microgrid system. It reduces the load spikes and electrical interference, and it also takes a backup electrical sources, energy sources. So shortly, we can mention it as it stabilizes the operation. Microgrid system stabilizes the operation. It also helps in load sharing. Also, it reduces the issues, electrical interference. Interference is nothing but disturbance. Disturbance, it is reduces the disturbance, and also you can use it as a backup. This micro turbine has been a very powerful tool in storing this energy device in case of microgrid technology. So this is the basic introduction of what is a microgrid technology, how the architecture is, and how the system works. Now, grid tie inverter. What is a grid? We know what is a grid. A tie is nothing but connected. An inverter is nothing but what is already an inverter. Now, for instance, I'm considering PV cell as an example here. So this is a picture of grid connected inverter. One grid is connected towards an inverter. So this grid is connected to a PV solar panel or whatever it is. Solar panel, or it can be a module, it can be an array or whatever it is. So this grid tied PV inverter is specific to solar PV energy. When it is a PV inverter, it is very specific towards the solar energy only, not another thing. So this PV inverter is a device which converts direct current into an alternating current, isn't it? So this converted power, it can be used in house appliances or ejected into electrical grid. You can also use this grid tied inverter in between the local power generators and the power grid. This grid connected inverters, it is also not restricted to a particular system, but also you can connect it to anywhere for using of power. Not only for the PV cell, but also for any other purposes you can use. So that is not, it's not going to create a problem of this. So this, the picture of grid connected inverters is given here. This is taken for an example, but it's different for any, I mean, it is different for other systems. So this, to make it safety or in order to operate it effectively by injecting this electrical power into this grid. So this grid connected solar inverter, it accurately matches the phase and the voltage of the sine wave alternating current. And that's how the power grid happens. So this some electricity corporations, they also pay for the electrical power which you inject into the grid. That is, maybe you may get some cash monthly by supplying the power. That's the meaning actually. So you know what is a grid connected inverter, but then what is a regular inverter does rather than this grid connected inverter, you should know, right? Because here also the inverter, it is connected to the grid, but then what is a grid connected PV inverter? It connects your home and the supplement. Grid connected PV inverters, it connect your home and the supplement the electrical grid in case of surplus power generation. But the inverter delivers power to your home appliances directly from the solar panel when the solar energy is available for use. It switches back to grid and in case of insufficient solar energy. But this grid connected PV inverters, they work side by side with the mains to deliver energy to your home wherever needed and whenever needed. They have a processing intelligence. That's why this microgrid is said to be intelligent, and it enables them to know when the power delivery is necessary and when it is not necessary. They sync the grid power with power delivery. That is the speciality of grid tied inverter. This regular or normal inverter, it is also called as off grid inverters. They cannot synchronize with the grid. They will never synchronize with the grid. They just supply the power abruptly. Instead of working with the grid power, they only connect the appliances into your house. They only function. They function alone. Standalonely, they'll be functioning. This off-grid or the normal inverters, they draw power from a battery, normal battery, and it converts from direct current and it outputs as alternating current. This regular inverters have to supply the power. They convert from DC to AC instantly to the appliances which we are using into. The energy must be quickly react and be over and up to the inverter's capacity rating. So that is the major difference between a grid connected inverter and a normal inverter. You can have a regular inverter for generating a grid, and you can use a grid connected inverter for a run all or most power in a hybrid system. When you move in for a hybrid system, you can go in for this grid connected power. When a normal grid is used, it is situated from 20 meter from the battery. You also use if it's the power is demand, or when you need a surplus amount of power. This grid connected inverter is best. So why it is actually best for solar panels? Grid connected inverter is more suitable for solar panels is they have several exciting features that makes the best for solar panels. Like using this energy, it reduces the global warming and also greenhouse effect. They have an added functionality besides converting the solar energy from AC to DC. Just apart from energy conversion, you have many other advantages using this grid connected inverter, and that's why when the solar energy is insufficient, the grid connected PV, grid connected inverter is in place. It plays a major role in drawing the power. That is the speciality of grid connected inverter. This grid connected inverter only has turned into microgrid tie inverter. A grid can be of many types, isn't it? So this microgrid is nothing but a special inverter which uses for PV panel. Now moving on to inverter topologies. We have seen what is a grid. We have seen what is a microgrid. We have seen what is a grid connected inverter. Coming into the inverted topologies, why we have to know about inverted topologies is it is not restricted. I mean, you cannot use a particular microgrid into a normal inverter. An inverter can be of many types. You cannot Say for example, if a normal inverter, you cannot use it for a microgrid, or say for example, if it needs some amount of power, you cannot abruptly use a normal inverter which you have used already. Everything has a place and everything has a need. According to that, we'll have to experiment, we have to analyze, and then only we'll have to use the microgrid connected system. And that's how we'll be looking into inverter topologies. The topologies is nothing but different kinds of inverter. This particular chart I have given because just to know about the application which I'm going to discuss in the last. As I said, for photovoltaic systems, this particular inverter topologies are sufficient to know. As I have mentioned since the beginning, I'm taking example as solar inverter. So these inverter topologies are very much sufficient to know about the solar inverted inverters. So if you see, it is divided into three, majorly divided into three. One is central inverter, string or multi-string inverter, and micro inverter. So this central inverter, you can also term it as a grid connected centralized inverter. So what does a centralized inverter do? The same thing. It is just converting the DC to AC or whatever it may be. Apart from the conversion process, what does these inverters do is each one has a specialty. For a central inverter or multi-string 5-level inverter, cascaded multi-level inverter, or boost half-bridge converter based micro inverter, or interleaved flyback based inverter, each inverters has a particular specialty. And that's why these inverters are majorly used for solar power. I mean, PV connected, grid connected photovoltaic systems, not only for photovoltaic PV systems, but also for grid connected photovoltaic system. These inverter topologies are very much useful. So moving to the application part, which I discussed, as the session is regarding the microgrid tie inverter. One application for that microgrid tie inverter I have taken. We are not going to deeply discuss on the complete paper. I'm just telling about the abstract of what it is and what it is done in that particular paper. It is 4-switched based 3-phase grid connected inverter to connect renewable energy source to a generalized unbalanced microgrid system. So from this you can know you have a grid here. A grid is connected to an inverter. Where it is connected, the entire system is connected to a microgrid. So this is one of the suitable example of a microgrid which is connected to inverter. Using the inverter or using the inverter topologies or using the grid connected topologies or using the microgrid technology, you can mismatch anything and you can come to a solution. This is one of the experiment which I am discussing by using an example. Since I have already mentioned, I'm using a solar power as an example for the entire thing. That's why I'm using these examples. So this is the basic diagram of the microgrid, which is connected to an inverter of all those switches. As I said, it is 4-switched base 3-phase grid connected system, which has generalized unbalanced microgrid system. Not much going into deeper of this particular application. I'll tell. From the name, you can say 4-switched base. That is 4 power semiconductor switch based 3-phase inverter. Okay, leave that grid connected. It is a 3-phase inverter. 4-switched semiconductor switch are used, and it is proposed for a renewable energy source. Renewable energy source here we're considering as a PV source, right? So this proposed topology can be investigated as a commercial one, or it can be used as a mostly it is suitable for commercial one because not residential purposes. This is not needed actually for commercial purpose, and when the supply need is surplus, this type of application is very important. So this, by using this generalized unbalanced microgrid system or using this particular microgrid inverter tie inverter, uh, the energy or the supply needed can be derived, but the output is different for each inverters. Here they have used a normal grid connected 3-phase grid connected, that is 4-switched base 3-phase grid connected inverter they have used. This inverter can be of different types, or even the grid can be of different types. The microgrid here, it is a generalized unbalanced microgrid system, or this microgrid system can also be as a normal one. So each phase of microgrid can be different. This is one of the example where Microgrid here, the renewable energy extractor is here from the left side. I'm just coming. The extractor, renewable energy extractor is here, and it is converted to PEC converter, ensuring MPPT of the renewable energy source. Here they're using an algorithm called MPPT algorithm. Any algorithm can be used, that is up to our wish. But then the final power which is derived has to satisfy the need which we are using, even if it's for a commercial purpose, or even if it's for a larger commercial purpose or residential purpose, or any other buildings which you are using. This inverters and the storage battery, all those things must be in agreement with the inverter which you are choosing, and it is also should be in accordance with the microgrid which you are choosing. The different types of utility grids and microgrids can be of anything, but then the basic knowledge of how a grid connected inverter is directly connected to a microgrid is what we have seen here. That's all about the application part. I'm not going into the modeling and analysis part and all, because that needs simulation and all those stuffs. So from with this, I'll stop about what is about microgrid tie inverter. That's all. Thank you so much for your time.
Thank you, Sujith.
Thank you,
nice,
sir.
very nice presentation.
Thank you, sir.
Thanks for accepting our invitation and present this session. Okay. If students have any queries or clarification, you can ask to Sujith. Students. On smart. I think no queries. I think so. It's very clear. I don't clear about your concept. Okay. Everyone, turn on your camera for photo session. Everyone can turn on your camera. Sujit, please turn on your camera. Please turn on your camera. Hello. Faculties and students. Okay, thank you. Thank you.
Thank you, sir. Thank you, sir.
Students, the feedback will be those who are actively participated students will be sent to your mail ID feedback link. You have to give the feedback through that link. Okay. The actively participated student will be receive the feedback link. Thank you for joining the workshop. Thank you for coming. Thank you.
Everyone,